And what's your thought on okay, so out of the machine, you can get a very complex geometry. Sometimes it's cheaper, sometimes it's not. Most of the time it's more expensive. Then you have to do surface finish. Like like in aerospace, space, okay, like you're spending boatloads of money anyways, but like what, how beneficial is additive manufacturing if you have to then do all this other stuff to it?
All right, I'm gonna cite Paul Gradle on this one, and I'm gonna add something else to that I add to it. So if you can do it without additive manufacturing, then don't do additive manufacturing, right? It's because it's complicated. It's not easy. And then I'm gonna add another layer. If you can get away without surface finishing, don't do surface finishing. There's many components that are going to have different type of applications that are not going to need the surface finishing. Now, the, I think the problem resides on the design. When you're going to start designing a component and you have that component in mind, what's going to be that final application for that component, and what are the requirements for that component? So at that point, you need to start thinking about the surface texture that's going to be needed. So then you need to design not just for additive manufacturing, that is another science, how you're going to build this stuff into this box full of powder, but also how you're going to do the surface finishing of these components and what's need to be added to a component in order to achieve the surface that you need to be using. And that costs money. And also, if you are looking for let's put basic example. You need a component that needs to have a surface finish of an RA below 1 micron, which translates around 40 microinches. And you need to have optimal fatigue performance and optimal corrosion performance. And you're going to build it through laser powder bed fusion. So you know already that the surface texture of that component is going to be rough, and you're going to be able to achieve it like that. So you need to remove material in order to achieve that polarization. So now you need to start thinking about if this component can be designed adding that extra amount of material that is going to be needed to achieve this polishing. And that's complicated. There's components that you can do that, absolutely, but there are components that you cannot do that it doesn't allow for that. The other is that you need high fatigue performance. I already talked about heaping process, so you're going to need to heap this component too. So that is going to be an extra charge that you need to think about. So when you're designing the component, you also need to think, okay, how I can make the best business case for this type of component. So where I can save money compared to the traditional way to do it. So there is stuff coming to play like weight reduction. That's a really big cost reducer right there. You're reducing material, so that probably is going to make it cheaper, and also in use is going to make it cheaper in the long run. The other one is part consolidation. So you don't need to assemble multiple components to create this type of artifact or apparatus that you're trying to build. That also is going to be cost benefits. So those are the type of stuff that you need to be thinking about when you are designing the component. Not just make an AM component for the sake of it. You have to come also with that business case, because if not, yeah, it can get super expensive.